Hey, good afternoon, everyone. Thank you for joining the lectures. I got 23, 24 people here right now. Let's give one more minute and see if all of us can join us. All right. And regarding the homework and the grade of first exam, I'm still working on it hard. I ran into some calculation issues in terms of some of your solutions. I'm working it out. And like I said, we will probably talk about the graded exam on Monday next week, and just to go over them. And I'll be reaching out to a few of you that have some troubles in the first exam and discuss some plan forward. Okay, so that's the progress about the uh, exams. Okay, and I want to quickly touch upon the homework. We skipped the homework last Thursday because of the exam. We will not skip the homework again this week. So I will be assigning homework. So please watch out, and we will definitely have homework today. All right. And about the quiz yesterday has been assigned as a deadline of next week. I think it's up there already. If it's not, I will make sure it's there. So please finish the quiz on time. What I'm trying to do is by next week, I want all of us, to have an estimation of your grades, current grade, so we know where we're at and have a plan moving forward. Okay. All right. So that's about it. Any question from the audience? Anything, folks?
Yeah, I saw that the quiz on Canvas is worth 100 points. Is it
Oh, that
supposed to be or?
that's probably a typo. It should be 10 points each.
Okay, thank you.
Yeah. Thank you. I'll correct that. Thank you. Any other questions about it? Anything else? Okay. All right. Well, if nothing else, let's come back to our main lectures. All right. And today will be pretty happy, I think, for all of us, because it's going to be very short lectures. I'm trying to finish up the irregular section lecture. All right. So last time we talked about irregular sections, and let's recall a little bit. What is irregular section, right? Section that has opening or duct or holes in it. That's irregular sections from where we stand. And Louis, any question from you? Okay, all right. So
Oh, my bad. I forgot to mute myself.
oh, no worries. Yeah, just making sure. So if we have an irregular section, right, the best way to deal with irregular section is to find out the compression and tension, and going from there, find the moment and etc. So on and so forth. All right. So this is how we find out for irregular sections. And we take an example of that, showing that when we have one opening in the section and how we go on and solve about that problem. Okay. And we arrive at a good answer and we're happy with it. So we left at a point that saying, what if we have an opening that is now fully covered from the section? So today I'm just going to walk you through one example like this. Okay. So on the left-hand side, you can see a section which is irregular shape, has an opening at the top actually. And missing piece like that will cause some problem. But in addition to it, I also have a duct or opening in the middle of it. Okay. So represented by this cross-marked opening here. And here's the geometry of the section. So it has these sticking out parts, 4-inch wide, 4-inch tall, missing part at 4x4 square, and the spacing between the edge of the missing part to the opening top surface 2 inches, and have a opening roughly square 4x4 again. And underneath it have 8-inch of concrete, 8-inch of concrete reinforcement right here, and 2-inch of a concrete cover in the bottom. And the total height of the section is 20 inches, and the width is 12-inch. Okay. All right. So this is the geometry that we're dealing with. This is the geometry we're dealing with. Okay. Now, how are we going to go and solve about this problem, right? So first of all, let's give some materials property as well. Concrete has a 4 KSI compressive strength. The steel has a 60 KSI yield strength. And we provided the bar area already for number 9, and the reinforcement area is 4-inch squared. Okay. So the question, of course, is find out the design strengths, nominal design flexure strength, VMN here. Okay. So let's try to solve it. So first thing, I want to observe the section, right? So I need to know where to start. So it is always safe to assume the steel U and start from the tension there. Okay, so the total tension force will be ASFY. So that is 4-inch squared multiplied by 60 KSI. All right, and that gives me 240 kips of total tension force, right? Total tension. All right, so now next step is we're going to balance the tension with compression. So T equal to compression C, and this gives us the ASFY equal to 0.85 F prime C, and I need a beta 1 C and B, right? Beta 1 C and B. Yes, but the problem is what? The problem is that I don't know the concrete area. I don't really know. And the Whitney stress block may not necessarily work here because I have an irregular section. So that's a bit of a bind here. What we're gonna do is we're just gonna assume that the compressive area is AC. Okay, that is to say we don't know. I don't know what is the area, but I'm just going to assume that. And with this assumption, I can then find out how much of a concrete area I need to balance the tension force. So I use ASFY, and 0.85 F prime C, 0.85 F prime C to get 240 kips total tension force divided by 0.85 multiplied by 4 KSI. And I got this number to be 70.6 inch squared. 70.6 inch squared. So that is the total compressive area I need for the concrete. Okay, now this is the compressive area, right? So I need to know what is the shape and the centroid, right? What is the centroid of AC? Okay, so before we know that, let's take a look, right? Let's take a look at the section where exactly we're at, right? So let me just copy this section here, right? That's the section we have. And shrink it here, okay? Maybe zoom in a little bit and show you what is AC, right? So naturally, you know at this point that AC is definitely not covering the opening, right? So you already know the AC is not covering the opening. And the reason behind it is what? The reason behind it is that we already had an example of covering it. So on purposely today, we're going to have a shaded area that I know is not going to covering it. Okay. Now you may ask, Bob, what happened in the exam if it's covering it? So you can quickly find out yourself, isn't it? You can quickly find out yourself. But now let's assume it's not covering. And then I can then divide the area into 3 segments. I call the sticking out part as 1, and I call this nice strip area in the middle 2, and the 2 sides of the strip as 3. Okay, I just want to call like that. So it will be easier to compute the shaded area, right? So how do I do that, right? So I can get area from A1 that is 4-inch multiplied by 4-inch, and I have 2 of the stick out, so I got 32-inch squared. And I have A2 that equal to 2-inch, which is the width, and across the width, which is height, and across the width, so I have 24-inch squared from 2. So what about 3? For 3, I don't really know the height of the strip here. So I'm just going to call it H3. All right. So now A3 would equal to what? Would equal to AC minus A1 minus A2. Isn't it? That's required, right? So I can find out A3, that is 14.6 inch squared. Then H3, which is the height, would equal to A3 divided by the width B, that is 14.6 inch squared divided by 12 inch of width, and I'm left with 1.22 inch of a distance. Okay, so with this, I can now compute what? I can now compute the height of my compressive zone because I now know that this is all the compression in this irregular section, and I call this A. Then A would equal to this fellow here, 4 inch, this fellow here plus 2 inch, and this fellow here plus H3. So that is 4 plus 2 plus 1.22 inch, and I got this number to be 7.22 inch. All
You
right.
said all that is under compression?
Yes.
Okay, thank you.
Yeah. So this is the effective compressive zone A here. All right. Now I got my compressive area and I got the shape of it. I need to find the centroid. And to find the centroid, I can take a reference line with respect to the top line here. Okay, just to simplify the approach, I'm just going to take reference as the top line here. And I don't know exactly where the center is at, right? I don't know, but I'm just going to call it Y bar from the top. Okay, and you must be very familiar with this process. I can easily find Y bar by doing what? By doing sigma AI YI divided by sigma AI. And that is A1, Y1 plus A2, Y2 plus A3, Y3, and divided by AC. That is A1 plus A2 plus A3, right? So plug the number in. So Y bar essentially equal to what is A1? We calculated 32 inch squared. So 32 inch squared. What is Y1? That is from the center of the 1 to the top, which is 2 inches, half of 4, right? So 2 inch, right? And plus 24 inch squared, that is A2. And where is the distance, right? The distance is between the center of 2 to the top. So that is 4 plus 2 divided by 2. So that is the distance, right? And last but not least, which is a 14.6 inch squared, that is A3, which is this fellow here. And the distance is what? Is, again, half of H3 plus the spacing of 1, which is 4, and plus a spacing of 2, which is 2, isn't it? So this is 4 plus 2 plus 1.22 inch divided by 2. All right, so that is the distance. And then divided by the total area in compression, that is 70.6 inch square, calculated before. All right, now with this, I can get my distance between the centroid of the compressive zone to the top, and that is 3.97 inch. So this fellow here is 3.97 inch. Okay, so you may ask, Bob, why do I need that? Why do I need a Y bar? Because I need JD, which is the distance between compression, remember, and tension. And JD would equal to what? ds minus Y bar, right? ds minus Y bar. Okay, that is the centroid. That is the centroid. All right, so be careful here. Usually we use ds minus half a, isn't it, in the rectangular section? But in this case, since it is irregular section, so we're not gonna use this. So this is only for irregular section. Ladies and gentlemen, you will have one at least problem in exam number 2 on this. Okay, all right, so keep this in mind. All right, that would be the lever arm. But once I have the lever arm, before I do anything in terms of moment, I want to check, right? I want to check whether the steel yielded or not. That is, what is the stress in the steel? Is it yield strength or not? So how do I do that? In this case, I have to use A. So A equal to 7.22 inch from previous calculation. So C, small c, and this is actual compressive zone. And I'm pretty sure by now, some of us might get confused already, but this is actual compressive zone. And that equals to A divided by beta 1, right? And this is 7.22 inch divided by beta 1 for 4K as a concrete 0.85. So I got 8.5 inch of C. So now I want to compute the strain, right? So epsilon S, which is strain the steel, assume one layer, okay? Assume one layer. I have two number 9 bars, so I know it's gonna be one layer, but assume one layer, right? And this equal to what? Equal to ds minus C divided by C multiplied by epsilon Cu. So ds is 18 inches, right? Minus 8.5 inch of C divided by 8.5 inch and multiplied by 0.003. So I got this number to be a 0.0036, which is greater than 0.002, so still yielded. All right, so naturally I'm pretty happy about this, right? So it yielded, but be careful. Since this number is smaller than 0.005, so you want to note here, not tension controlled. It's not tension controlled. All right, it's not tension controlled. So this is a important message. Okay, so with this, I say since it is not tension controlled, right? So I have to recompute phi. Okay, so the last step, what is VMN? Right? What is VMN? So before I do MN, let me do phi. So phi should equal to 0.65 plus the steel epsilon s minus 0.02 divided by 0.005 minus 0.002 multiplied by 0.25. Okay, so bring the number in. I got epsilon s is 0.0036 minus 2 divided by 3 and then multiplied by 25. So phi ultimately equal to 0.78. Okay. All right. So moment of truth. Now I want to find by design flexure strength Mn. So T tension here, ds minus half A. Right? So I can get the number. Is that right? Can I do this? Right. So if you're smart and you've been watching, you know this is not right. What happened is that I need to actually do this. Okay, I need to do ds minus y bar. Okay, not half A. All right. So if you do half A, you're gonna have a problem, right? So this is 240 kips. Okay, and multiplied by ds is 18 inch minus 3 point something, right? 3 point, where is it? 97. Okay, just to round the number up, and I'm just gonna say approximately 4 inches. Okay, so this gives me what? Let me make sure my calculation's right. So pull my calculator out. I have essentially 14 inches of lever arm to convert. So I want to divide by a 12 inch per foot. So 14 divided by 12, I got a 1.16 multiplied by 240. So I have 280 kip feet. Okay, so now finally VMN equal to 280 minus, sorry, multiply 0.78. I have a final moment capacity of 218.4 kip foot. All right, so this is the final number. This is a final number. All right, so along the process, there's just several key points, caveats, right? First of all, I determine my AC, which is the area compression, utilize tension equal to compression. All right, and then I find out where exactly is the neutral axis. Right, this line right here is the neutral axis or equivalent neutral axis. Right, so once I find that, I can find my A and find the centroid of the compressive zone. So this part is critical. All right, this part is critical. and then I go on and find my capacity. Okay. All right. So this is it for today, actually. So any questions? Any questions, folks? Anything?
No.
All right.
Yeah, Bob, I have a question.
Go ahead.
So back whenever you calculated the third region of the area, why did we like? Shouldn't we have to take out the like area for the opening? The H3, A3.
Oh yeah, I think I. Sorry, I missed. I think I made a mistake here. Okay,
Okay.
folks. Yeah, this is oversight. So I made a mistake here. So this should be. Jesus, I forgot about it. So this should be 4 inches,
Yeah, B minus 4.
right? Right. So
Okay.
this should be 8. All right. Apologize for that.
Okay.
I might have to make a lot of corrections. So I will upload the corrected notes. Okay.
Okay, thank you.
Yeah. Sorry about that, folks. I made a mistake here. So let me circle out the numbers could be wrong, and you don't have to worry about it, and I will clean it up and upload to the canvas the correct number. Okay. So just give me 1 second. Let me label the number that could be wrong. Thank you very much, Tom. All right, white bar. Okay, so this should be problematic. Problematic too. Here, this as well. Okay, here. And almost everything I have to change that. Okay. All right, folks, don't worry about it. I'll fix it, okay? It's not a whole lot. I made a mistake here while transferring the notes. All right, okay. So this is the process. So let me go back to AC here, okay? Now, correctly, we have to correct this, but we know AC, and we can find A, and we can find Y bar, which is the centroid of the compressive zone, and then we can check whether the stress in the steel yielded or not, and then finally get our VMN. Okay, so the process is not complicated, but you can easily make a mistake like I did, which I'll correct and upload the correct note. Okay, but before I go, I just want to leave you a quick quiz. All right, so this is quiz number 6. Like I said, today is fairly light, but I still want to talk about this. So if you now know how to calculate an irregular section with a hole in it, and that's not covering, I mean, it's not being covered by the compressive zone, I want you to take a look at these 2 examples. Okay, so let me just maybe draw it a little bit differently. Okay, I have a section on the left, let me call it A, and I have a width of that of 16 inches, and this is 4-inch in 4-inch. This is more like a heavy I-beam with a lot of mass in the bottom here, okay? And let's just call this 4-inch again, and top 4-inch again. And then this naturally is 8-inch, actually 20, so 12-inch. Yeah, and I have a bar right here, and let's just say AS equal to 2-inch squared. All right, so now this is the section, all right, and I have a cover of 2 inches here. I want you to compare this section, the VMN, okay, compare this with this section here. So section B, okay, and they're in the same height, but instead of eating out, I have an opening right in the middle, okay, and I say this is about 8-inch, and this is 4-inch, and this is 4-inch, and again this is 16, same thing, and here I got 12-inch again, basically same configuration in terms of reinforcement, 2-inch squared, and the distance is 2 inches. Okay, and this configuration is B, okay, and I want you guys to check MNB. All right. Now, what is the quiz? The quiz is simply determining is it bigger, smaller, or equal. just to check the design capacity for both of them. And that's the configuration. On the left is A, on the right is B. Okay. All right. So hint, do not think too hard. Do not think too hard. Okay. Think.
This
quickly.
image is in the notes, right?
Say it again.
This image is in the notes, right?
This image is in a note.
In the notes in the PDF.
Not
the
yet.
maker.
I'll upload it. Right.
Yeah.
Yeah,
Yeah, that's what I mean.
Definitely yes. Always right. My quiz is all in
What's
the
the
notes.
FY and the F prime C?
Oh yeah, sorry about that. F prime C will be 4 KSI, and FY is 60 KSI. And do I need anything else? No, that's it. Okay. Any one of us can think of a quick answer? Make a wild guess. Anybody?
I'm gonna
Equal.
guess for the same.
They're equal.
Are they equal?
Got it equal?
Or the above?
Since the area missing's the same, or does it have to do with the centroids?
Okay, that's the right answer, actually, for the quiz. So it's a freebie for all of us. That is indeed equal. All right. Why I want to bring this quiz in place is that, okay, now this is indeed equal, right? Because you can see that I basically dig out the opening and rearrange it and become the left configuration. Okay, so it's a freebie. I still gonna post it and you can answer it. And if you want to earn extra credit, you can actually compute it out because this is a last year's exam. All right, but I want you to remind ourselves that if I have a section like this, okay, I have a section like this, and then I have I-beam like that, right? That's essentially is. They may have the same moment capacity. Okay, as long as they have the same openings, right? So you may ask the questions why we design them differently if they have both the same moment capacity, and the answer is shear. Okay, the answer is shear. They may have a different shear capacity when we put the stirrups in them, right? Think of it, right? So think of it. Okay, all right, folks, that's it for today. And sorry, yeah, Abigail.
Do we know when we can expect to get our exam grades back?
Yeah, like I said, it's gonna be either tomorrow or Saturday. I'm working on it.
Awesome, thank you.
Yeah.
What about
yeah,
homework
no problem.
4?
4 will probably be Saturday evening. I have finished most of the exam. I have to spend some time uploading the grades on the exam, then get back to the homework 4. But I expect all of us should have all the grades, like exam homework number 4 and quiz 5, 6 together by next Wednesday, the latest. So we have the grade, like midterm grade. All right.
All right, thank you.
Yeah. And I'll probably reach out to you guys once we have the midterm grade out, okay, to talk about some possible issues and solutions and such. All right. Okay. So again, sorry for the mistake and typos. The number issue I made here by left out this -4 inches. I'll make correction and upload the correct notes. Apologize for that. Thanks to Tom again for bringing it out. And this quiz 6 is still a freebie if you watch the lectures, basically. Okay, and I'm gonna upload this quiz 6. You can quickly just flip say equal or whatever. And if you want to earn extra credits, just put a number there and that will give you extra credits. Okay. All right, well, I'm done today. It's a light lecture, like I said. Any questions, you can stay behind, or you have other issues, please stay behind, okay? Thank you very much.
I have a question.
Go ahead.
So if we're doing for the extra credit, we only have to solve one since they're both equal. We don't have to like show you both works.
That's right. So
Okay.
I can tell you it's gonna be worth of 2 extra points on the quiz.
Yeah.
But still it's 2 points, right? So
Okay, thank you.
not a problem. Yes, sir. All right, so I'm gonna stop recording to save some of the data, but you know, feel free to stay and ask me any questions, okay?